Good evening, everybody. Welcome to a live stream. This is going to be a working session, not a produced live stream, and I'm not going to care if somebody's phone rings or we look unprofessional. That's not what today's about. For example, working session, not a produced live. If I have an echo on my screen, that's exactly the example I was talking about. So we are going to have a working session talking about PCB design, tools, libraries, how we can do this better with less rework, what lessons each of us have learned in this community, and basically how can we do this better. And I have some goals. I have not planned for this because I spent the day with Eric Carson getting a medical procedure done to help him get back to running. And that was the whole day, and I was going to spend some time today. But I'm so glad he was feeling better, and that all went well today. I got to see a hi Eric Carson, which was very funny. It was great. So, but let's get started. Say hi to everybody who's here so far. We do have some room. So, Jay Beavers here. I think it's Beavers, not Bevers, is it?
Beavers. Yep.
There you go,
That's
Beavers.
like the animal.
There you go. It's my daughter is a Minot State Beaver. Look at that.
Very cool.
And we have Mary Elizabeth from Project Vive, now more involved with us than before. We love it. And Chris Young is here as well in incognito mode because he is not at his desk anymore today. But I have a lot of the stuff you've done here to show, Chris. So if you want me to show a board of yours, I probably have one within reach. Okay. And you're still muted, so feel free to unmute. I'll unmute you. Oh, I can't unmute you, but feel free to unmute when you want to. Okay. Our goal for tonight is to make progress. We had some questions. I guess we should start with that. We had a question come up about a week ago that said, "Hey, what tool do people use for designing PCBs?" As Paul Hewitt asked that. He's at the ACE Center in London, and many people answered him, and we got all the usual suspects, right? So we got Altium and PCB, Altium and Eagle and KiCad or KiCad, however you say it. I'm not going to have that argument with anybody here. We had all the usual suspects, along with a couple others. Fritzing came up, and another one that I didn't use, I've never used, came up.
OrCAD, maybe?
OpenEDA or something like that came up. Lots of tools are out there. I will tell you what I use. And so halfway down the thread of that conversation, Paul said something like, hey, we should get a library of commonly used AT devices and footprints and make them common. And I agree. And the weird thing is I'm in the middle of doing that for myself, and it shouldn't just be for myself. So what I'm really making is all the footprints of the Adafruit boards that we use as daughter boards to power our designs, because most of my designs, that's what I'm making. I'm making these interface boards that take something that usually Adafruit has made or the Raspberry Pi Foundation has made and turns them into something else. So,
Hey, Bill, it says he's backstage.
It says he's not connected. Glenn says he's backstage. It says he's backstage. Well, let's do this. I am going to kick you out, Glenn, and then you will be able to rejoin. So I'm going to do that. When you rejoin, you should come back clean. That has been the solution in the past. All right, Paul Hewitt says he's here. Okay, let me post the StreamYard link here. So we have room in the studio. Join us. So there is the link. I just posted it on all the channels, and here is Glenn. Hi, Glenn. How are you?
Good.
So, it said for a second it said device is not connected again. So I hope you're still there. I don't hear you, and it says, "Are you there now?"
I'm talking. I don't know if you can hear me.
I can hear you now. For a second, you were there, and then you went away. Now you're back. So I don't know what your camera situation is. I don't need to see you. I know what you look
Yep,
like.
not worried about it. Thanks.
Yeah, so it's all good. Glenn, for folks who don't know, Glenn is a AT designer and has made a bunch of AT devices, but the biggest one people know about are the Prox Talker and the Prox Pad. He also does overlays for like key guards for devices and things like that. He runs Logan Tech.
Braille label makers.
And, oh, that's right, the Braille label makers. I forgot you made that. So I'm not. That's not in my wheelhouse at the moment. But yeah, it's a cool device. It's like, it looks like one of those old Dymo printers, electric ones, but it prints Braille, which is pretty cool. So welcome, Glenn. I don't know how much. I have no idea. We've talked a million times. I've never talked to you about PCB design, so we'll have to catch up on what you use and things like that.
It just looked kind of interesting what you were doing, and I've been talking to a lot of different people who are trying to make new products, and your name came up earlier today, as a matter of fact, and I just thought this would be a kind of a fun thread to follow.
Yeah, absolutely. So we will. I do hope somebody from the so Paul's there from the ACE Center. I think Paul's at the ACE Center, but it's got to be the middle of the night for him. He's in London, so kind of cool that he's up. So he's in the chat. I can see the chat. If anybody wants to post comments, I'll see them pop up here. I do have Discord open on the Adafruit Discord, so I will try to watch that as well. But I have way too many windows open, so I'm not gonna do this well. But let's start with my answer to this, which is I use Eagle. Okay, Eagle from Autodesk, which originally from EagleCAD, I think, but now it's from Autodesk. Is free for the kind of boards that we make. Paul says it's 1:30 in the morning, but I've got a cold beer. Well, there you go. So Paul's ready for this discussion, and you are the one who started it, I think. So let's get you the answers you asked for. Okay. Somebody just said here, but on that particular thread, which is in the group, it doesn't tell me your name, so I don't know who you are. Say who you are. Okay. Again, join the StreamYard if you want to come on live video. I would bet that Paul's not, because he has children or a wife or significant other in the house, and he's not going to join us. So I use Eagle, EagleCAD. Jay, what do you use?
So I use Altium, and the reason that I do that is that I do larger board runs. And I found the contract manufacturers want things exported in very specific ways. And I was having trouble getting the designs from KiCad into kind of what they wanted.
So was that more for assembly, or was it the actual PCB boards?
Oh, it's the assembly. Yeah, PCB is pretty straightforward.
Right.
Yeah.
I've seen that too. So they want the parts list in a very, like the bill of materials, they really want
it's more like the details of the PCB layouts and the through holes and stuff, so that they can do pick and place automation.
Right.
They need I don't know what I'm talking about it. You know, it's fine.
Gotcha. You just know that KiCad didn't give you what you needed, and you went to Altium and it did. That's
basically it. Yeah.
That's a fine answer. Mary Elizabeth, when you did yours, what did you use? Do you know?
So we started out EagleCAD. Then I emailed Altium and told our story of our company, and they gave us a free license. So we used that for a few years, which kind of what Jay said. I mean, because we also had some funds, and we're doing a lot of different projects. So when collaborating with people that wanted to get on board with Project Vive, that's what they were using, was Altium, and that's why we heard about it, and we wanted to be able to kind of simultaneously work on things, and so for compatibility. But then we also, OrCAD was having this sale every like 2 years or something. They will have like a full license. You don't have to pay subscriptions for a cheap price. I have my it comes with a little dongle.
No, really has the old school dongles. Wow.
Yeah, old school dongles. And the thing is like, you know, with the Altium thing, like we just every 6 months we'd have to like retell them like, hey, we're using it. And then, you know what I mean? After a while it gets old. Like we're supposed to like be some big company that's making a lot of money and like finally pay for it, which was probably like what the idea was that would happen.
Right.
But yeah, there's just a little USB dongle. But yeah.
Gotcha. Did you like Orcam better, or did you?
OrCAD, yeah.
OrCAD, I mean?
More than EagleCAD.
Okay.
And
Right,
that's also what a local manufacturer here, Centroid, my dad's company, they
Gotcha.
use OrCAD too. So that was another reason.
Easier way to do it. Chris, I think all your boards have been done in Eagle, right?
Yeah, everything I do is been Eagle. I used it back before they got bought out by Autodesk, and just continued with it. And it's occasionally you can get something out of Eagle and export it to Fusion 360.
Yep.
And of course, I'm always building a board and then building an enclosure around it. And
right. That is one of that new feature is one of the best things about, in my opinion, it is one of the best reasons to use Eagle is the fact that you can take your board and do a round trip to Fusion and back and design and it'll even give you the components on it. Like if the provider has given you the CAD program, it'll actually give you the thing that looks like the component. But even if it doesn't, it'll give you the footprint that you can elevate up just by measuring the heights. So you can really make something useful really, really quickly. And then you'll already have the places for the mounting holes, and you'll already have the places for, how to hold things down with clips and stuff. So I agree. That is one of the better tools. Now, Altium may do that as well, but it won't do it with Fusion. And so you immediately get into a much more expensive piece with that. So, let's, there's, as an overview, I think if anybody wants to type what you guys are using in the chat, I will watch that as well. My reason for using Eagle is pretty simple. I follow in the footsteps of Adafruit, not because we're close. I know Lamore and Phil, but it's not because of that. It's I want to be able to take their designs and rip them off, and they license their designs to let you rip them off. And I am 100% okay with the license implications of having to be able to, or there's our MIT or public domain. You actually don't have to do much with them, but I have no problem giving those back, and therefore it makes collaboration with the people who are making the boards that I'm basing these on very easy to be using the formats that they use. So all of their stuff is in Eagle. And I'll show you something, which actually is, I'm kind of skipping. I have a stupid, what I'm going to talk about tonight that I started literally 3 minutes before we started the stream, because that's how we roll here, right? But it is on there, so at least I'll get the one thing on there. I put together a little list of reasons that I like this. So if you take a look, let's do it this way. So I found these guides. The first one I ever saw was actually this old guide on Adafruit's blog. Let me do this. There you go. Which is it's in their learning guide. It's called K-Town's Ultimate Creating Parts in Eagle Tutorial. Right. So Kevin Townsend basically walks you through everything you need to know to create parts in EagleCAD. And it's way more than I needed at the time, but it got me realizing, oh wait, somebody's been here before and was willing to write down how to do it. I can probably walk through this. And I did. And I made a part. Before I actually made a board, I had made a part, which is weird. Usually you're using like stock parts, but I was just playing. So I did that. It turns out there's another one here that this is an older guide that says how to find and use the PCB files from Adafruit. And another one showing, this is a weird one. This uses an obscure part of, it's obscure to me, a very obscure to me part of Eagle called design blocks. That lets you take sections of board layouts, in other words, board files, sections of the board files, not parts, collect them up into a set portion of the board that you're working with. So like maybe you've got a power regulator and a couple passives and a jack, and you're always going to use it the same way. The idea is you can highlight it, you get it laid out the way you want it, and it'll keep that in a design block that you can then drop it in another board later. Well, this guy actually wrote a board, Brian Seipert, wrote a guide on how to take Adafruit's designs, rip out just the headers from the boards that you're going to use, and then reuse those in your design. So when you look, what you end up with looks like you made parts out of all the footprints, but you never actually make parts out of all the footprints. And I did this for like the first 5 boards that I made. I didn't use Oshpark, I used PCBWay, but all of them went through the process of extracting out portions of their designs and then putting them back together in my own style, right? To accomplish what it was that I wanted. So between all those guides, I made a long way into Eagle, and I kind of enjoy it. Can I ask you guys something? Do you guys find it actually relatively enjoyable to route a board, or is that just me?
I mean, it can be fun, especially when you're like wanting to make it nice and clean and like, have everything organized and like exactly where you want it.
It's like playing the game Flow. You ever play Flow? Where you got to get the things over and under each other, and you got to be able to work it out so that none of them hit each other. It's an online game called Flow. But when I first started doing PCB design, I actually told Lori, my wife, I said, "You'd love this. You play Flow all the time. You should lay out boards." Chris, do you enjoy this?
Well, the fact that I never took any kind of electronics or electrical engineering or circuit design course in my entire life, and the fact that I could steal some schematics out of another board and put together my IR board and went from there, and the damn thing worked.
Yeah, right. It's kind of shocking.
Freaked me out to no end,
Yeah.
So my IR board, for one of the earliest kits they had was a gadget called a TV Beacon. And it was a little gadget, a little battery powered thing, and they had programmed into it the power off sequence for every brand of TV that they could find. And you would walk into your favorite sports bar or consumer electronics store and hit a button, and it would shut off every TV in the place.
It's great.
It was a real bit of anarchy technology there. And so I ripped off the infrared output portion of that gadget and made my IR output board.
Which is the right-hand side of this, right?
Yeah, and then we incorporated that back into some of our other designs.
Yeah.
And the fact that it works just amazes me. But yeah, my original IR board has gone through about 3 revisions, and so it's been fun.
Yeah, no, I enjoyed making this one with you. This is the combination that takes a footprint of the Cutie pie, pops it on here, and then adds basically Chris's infrared board on the right, and it pops on top of a Raspberry Pi Zero, and it basically makes an Arduino Yun, right? I mean, isn't that effectively what this is, Chris?
Yeah, it's not Yun compatible, but it's an AVR type board or Arduino type board.
Yep.
Sitting on top of a Linux board.
Right.
And
so this can do all your PWM and your fast stuff.
Yeah.
And which is what this needs, right?
It communicates in our case over the UART to talk to the Linux thing.
Right. And so what this ends up doing, by the way, from an AT perspective, what this does for Chris is it's a Wi-Fi infrared controller for every device in his house, right?
Yeah, right? I can pop up a web page on my computer and click on buttons, and it will change the channel on my TV or call up the on-screen guide or
Right. And the
do
whole web
whatever I
page is
want.
hosted on this Linux box.
Right.
Yeah.
Right.
Which is kind of crazy, right? So we've all kind of ended up in nearby places, right, for various reasons. At this point, I'm going to show some of the boards that we've done. There are a couple of people who aren't here that I'll talk about, but they may show at some point. But I'd like to kind of show kind of the range of what I mostly do, and I'm just got the question: is this the kind of designs that most people are doing, or are people doing other things that? Oh, Glenn Dobbs says, "ECAD star," I'm told. Glenn, I'm sorry I didn't ask you. I don't know why I didn't think when I went all the way around the horn. I didn't ask you. I'm sorry about that. So let me show you, because I happen to have this pile here. This way. Nope. There you go. And let me turn off that stupid marker up at the top there, because it's just on top of Jay's head and bothering me. There you go. So
I thought it was an improvement.
well, I can put it back. Anything bigger? I got some lesson picks ones I could try. StreamYard on, but no. Okay. All right. So John Jordan and I, the very first board that we did at AT Makers, John Jordan and I, let me do these kind of one at a time here, made this guy, which was obviously the most frustrating thing that I have done in a long time. So this is a really good idea that we really did not execute to its fullest. And that's, John's the most frustrated about it. I'm the second most frustrated about it. But this is a really neat board. And we had this assembled by PCBWay and shipped back to us. And it looked great. And the cost was great. And we were all excited. And then we went to put it in production. And some unexpected environmental issues made it not work. So this actually is a feather wing. So just like a lot of the things we make, a feather will stick on top of it on this footprint right here. And it's got it has a port expander here, and then two relay drivers, and the relay drive and a couple of passives. This is a I2C device that then connects over these headers. And basically you can turn on and off these relays, but these relays are set up in a very interesting way. They're not on off. They're actually set up to make routes. So basically you can set up routing between these so that if you want to have one switch, that then you say, okay, the incoming switch comes in on this pin, and I'm going to not replicate it, right? We're not going to go on and off when the incoming thing goes on or off, but we're actually going to send the signal between these relays and change where the path goes. The driver for this was, we had people who could move their fingers so fast, and Jim Lubin was one of them, that the relays, if you actually tried to mimic what he was doing, it wouldn't keep up. And he was doing Morse code very quickly, and it wouldn't work. So we made this really neat routing board. And the problem is we put it all the way into production. We got it out to Jim's house in Seattle, and the magnetics of his lighting and his bed triggered the magnetics in like the electromagnetics in his room triggered these relays to send signals out through this board and freak out the feather. And it was constantly resetting, and we never came back. And of course, if you look, we had all kinds of things wrong on this board. We had no ground backplane. We had little tiny traces. Like, there's all kinds of things that we did wrong just because we didn't know any better, right? And we just kind of went forward with the design, and really probably should come back. I still think it's a very good idea, right? I really still think that that's a very useful way to be able to route signals as they go through these relays. But again, if you look, even this first one that we made is a board that takes on a microcontroller from Adafruit with the feather format and turns it into something specific for AT. Okay. By the way, John Jordan is I'm sure very glad he's in bed sleeping and not here grumping out with me. Let me see. There's a comment. It's from John Jordan's here. There you go. Look, there he is. So that Facebook user is John Jordan. So it doesn't show me your name because you're in the group. If you want to go to the actual stream that's going to the page, I'll be able to see your name and put it up there. But I'm glad you're here, John, and I hope you're less grumpy than I'm making you out to be. But I know you're frustrated about it. So we made this one. Probably the most successful board we made. Well, the second most successful board we made would be this one. Let's see if I have one that's here. Here's one that's not in a case. This is a USB filter board, which we use to make the IntelliKeys keyboards. We take in the IntelliKeys keyboard here and we output normal HID keyboard there. And this is something that we can do all kinds of madness with this, right? There's all kinds of ways where you can turn a mouse into a gamepad. You can turn a gamepad into a mouse. There's a million things you can do by converting USBs to USBs. And again, it's Adafruit board sitting on top of just get rid of the wiring. That's all this is about, is get rid of the wiring. And all of a sudden, it's super reliable. We can put it out in the field and it won't break. While we're on that, by the way, this is the latest version of that using the Cutie Pie and the back. That's got a double board on it. I'll show you this. This is just stuck. Sorry. There you go. So it's got the Cutie Pie instead, which is great because you can use several different types of board here in this format. It still has the trinket here because this is the only one that'll do USB host at the current time, but we're working on that. This is the one that Chris and I did. Again, it's a board that takes an Adafruit board, puts it on our thing, and then we pop it onto a Raspberry Pi board. This one's the key switch. It takes in 5 jacks, routes them into a trinket, and turns this into a very inexpensive $12 switch interface. And then probably the most popular board we have. Oh, well, I'll do this one first. This is probably the newest one I had made. It's kind of neat. It's got, this is the actual board. It'll go on any microcontroller. But it actually has a little SSR relay on it. And it gives you 2 outputs. So you can drive it with whatever device you want. But it gives you 2 good outputs, and it's got these. While these are plated through-hole mounts, they're through-hole jacks. They also have screws to mount them on the side of an enclosure, so you can actually get 2 outputs on an enclosure, and then just wire it to whatever it is you want to control. It's 3 volts. It's so you can wire it up to Raspberry Pi or anything else that you need outputs on. So I did that one recently. That actually, Chris, is this in use for you, or are you just testing it at the moment? This SSR board, are you the one that I made you? Are you using that, or are you just testing it at the moment?
I don't have one of those.
Well, no, the one that I made you on the feather.
Yeah, you made me a custom one, and that's the one I couldn't get work today.
Okay, so but is that going into production, or are you just playing with it?
I'm just playing.
Okay, you don't need it in your day-to-day life yet.
Well, no, yeah, I do. I mean, that's going to be my eye blink.
Oh, for the evening time. Well, it'll be your eye blink whenever you need it.
Yeah, whenever I need it.
Right, so
let me throw in a little lesson that I learned in developing my IR board that you may want to do in the next revision of that particular board.
Mm-hmm.
You didn't send me a board like that. You hand wired me a custom one, a prototype board.
I did. And
your reasoning was you didn't have power and ground pins to spare.
So I didn't have, so that was, there's
And
two
so,
reasons for it, but that is certainly one of them. Yeah.
yeah. So one of the things that I said my infrared board had been through a couple of revisions. My latest one has about 5 power pins and about 5 ground pins. They're just sitting there in case I need them for something else.
Yeah.
And I discovered that in wiring that IR board into something else, of course, it has a need for power and ground itself.
Right.
Well, if you connect that to the feather or whatever you're using it with, then you've used up your power and ground on the feather.
Right.
If you need it for anything else, then you have to start splicing wires and making Y connections and
Yeah.
all sorts of weird things. So
Yeah. So
my advice is when you're making something, well, and like on the Cutie Pie, you threw in some extra 5-volt and 3-volt.
Yeah, right here. I was just going to show them that. So like here,
And
we got
some extra
power.
ground.
We have over here in the power section, we've got 4 grounds, 2 3-volts, and 2 5-volts. Right.
Yeah.
And that was by your insistence. I don't want to say suggestion. By your insistence that we do that. Right. And I'm with you. I'm 100% with you. It's a very good advice.
So if you go back to redo that relay board, we need to put some power and ground lines in there.
Yep. I also think that when I do this relay board, I'm going to make them solos. I won't use the 2. This is a dual relay SSR, and I thought, oh, it's dual. I'm going to put 2 on the board, and that will be a great idea because it'll be, I don't know, $1 cheaper overall bill of material if I do it that way. But it also makes it much harder to position in an enclosure. So when I redo this, I'll make it 1 jack, 1 SSR, 1 resistor, and you're right. We'll have room on one side, and I'll put, 2 ground or 2 3-volts, and 2 grounds or whatever, however many I can fit on there. But it is a very good point.
Yeah.
Okay.
I would also say your switches do look a little too close together. I've seen switches with large, plastics on the end, and you might not be able to put them both in at the same time.
So the idea with this, just so you're right, and it's another good reason to have separate ones. I will tell you that the reason the goal of this was for me to design enclosures in Eagle, and just be able to pop this out the side. So I would have control over whether or not where those holes were. So I think that would solve it. If I'm making the cases myself, which I do a lot of, I could use this. But it certainly is easier if I just make them solos, right? The real goal with this, you guys can't see any anymore. Sorry. We're all looking at Mary Elizabeth. She's prettier, but she doesn't have the devices. So the idea, what I really liked about it was that if I placed these pins on this board in the right order, on both the Feather and the Cutie Pie and the Itsy Bitsy, there was a place with the ground and the pins in the right place where I could literally just tack them together and be able to make a little board like this, which was kind of the goal. But you're right in that in general, you can't bet on the spacing of these being correct unless you're making your own enclosures, right? Was that your point, Mary Elizabeth?
Yeah.
Okay, good. We do have a question, and it's not at all a basic question. So Paul Hewitt says, question for some time, how are you actually connecting the Adafruit board or Cutie Pie to your PCB? It doesn't look like you're using any header pins. I'm not. I love this. So these boards, let me see if I can, let's do it like this. Make this easier. Shit. Sorry. Let's look at like this. All right. I wish I had a magnifier for you. I don't. So these boards, these new ones from Adafruit, have what's called castellated pads here. So if you'll see these little dents on the outside of them. So what those are made for is you treat this like it's a surface mount part. And so when you assemble it, you take a blank board like this, and you'll see it doesn't have holes. you lay this on top of it, okay? And if I actually had let me use the right one. That's the new one. So you lay this on top of it like this. You align those things, and you just tack down one corner, and then you go around and you just solder them to each one. It's really helpful if you put a little bit of flux on the board before you do it, but it just it lets you directly solder to the board, and when you're done, you end up with a board that looks like this, which doesn't have header pins. You can put whatever you want on the back, so you use up half the space, and it even lets you do really super cool stuff like this, where you have a Cutie Pie on one side and another Cutie Pie on the other side for making those really cool USB adapter boards. So I got this done. I was all excited about it, and it didn't frickin' work. And it didn't frickin' work because Lamore, Lady Ada, got cute. I got cute. I don't want to say she got cute. That's the wrong way to say that. That's disrespectful, and I won't ever do that to her. She changed the schematic. She changed the design of her boards, because if you look at the trinket, I'm sure I have a trinket here. This guy. These boards, if you provide power on the 5-volt line, they will let you use this as a USB host. And on the new ones, she mimicked the Seed Zhao, which was what this was originally based on. And there's a one-way diode, so you can't, by putting power on the 5-volt pin, it will not let you use this as a USB host. And so if you look really careful on this side, I don't know if you guys are going to be able to see this. There is a diode right here. See it right there? And on this side, I have removed it and put a tiny little wire in there instead. And that's what lets me get away with this. But that's not a good design, because I'm not going to have the high school kids taking diodes off the boards. And they can certainly assemble surface-mounted parts, but they can't do that. So Lamore has been great on that. On all of the boards, the castellated boards since then, she has added a little jumper on the back that lets you get around that diode. And so that's been wonderful. But this particular board cannot be a USB host board. So, but that's a long answer to your question, Paul. I really enjoy these.
No, we made an assembly video for the Cutie Pie hat.
Yeah.
It actually shows you soldering those castellated pins onto that hat board.
It does. And I can post a link to that.
Look up my learning guide for the Cutie Pie IR hat, and there's an assembly video.
I'll post the link here. I know you guys can't see it, but yeah. So we made it's a very interesting video where it's Chris talking in my hands, and we are, I don't know, 1,200 miles away from each other. But it works.
And then part of it, I sped up your video.
Yeah, my very fast hands.
Yeah, so. Because it was, it took us a half hour to put the thing together, and I had it down in about 10 minutes, I think, with my narration and some editing and some speed up and stuff.
All right. So, for the folks that are here, any questions on this so far? Is this what other? Let me go back to this view here. I keep finding the wrong view, no matter what I do. Okay. I think this is most of what Paul is doing. I'm pretty sure it's most of what Milad Ha is doing and Jake MacGyver at Makers Making Change is doing. They're not here, but if they are here, pipe up in the chat and we'll be happy to comment on your thoughts. But Mary Elizabeth and Jay and Chris and Glenn, are there things that I'm missing here? Or is this primarily is this mostly what we're going to be doing in the near future?
So, with our products, the goal is always to get it to production and be able to, have enough so that you can get those cheaper prices. But, very similar when we started out, it was those same things, using the feather. We had the M0 Cortex we used, to translate switch inputs into HID keyboard strokes and, things like that. With that being said, where I'm working now, we have, a pick and place machine and an IR conveyor. Actually, I could post a little video I took last week of it if you guys want to see. Yeah, I guess that's really all I had to say is as soon as we could try to get, because Adafruit is cheap, but if you're going to be, a lot of people are going to be using these, and especially if you're adding like, this component here, this component there, like getting the jack, like, it can add up pretty quick to where people, you're spending and you're not even counting, your own time on it. I don't know if that's the kind of discussion we're having right now, but
we can have every discussion that's
right.
in the air, right? We don't. I never try to guess where the discussions are going to go, Mary.
Right.
So it's not. I think you're right to a point. I think that to the point where we would like AT devices to be more accessible and more commodity. You're absolutely right. We should treat them like commodities, and we should price them, and you should make them. And it's certainly true that, for example, I don't know if I have one here. It's kind of, oh yeah, here. So this board, the particular Cutie Pie that's on there, has an RP2040 on it. I think maybe it's got a SAMD21. The RP2040 is available, and if you buy the chip, it's $1, and it is 90% of what you need out of the Cutie Pie. The thing is, it's a package that you need a pick and place to assemble. So if you're going to make a part, you want to do it yourself, and you want to use a pick and place, or you want to use an assembly house, because it's BGA. There's no way you can hand solder this thing. I don't think anybody here can do that. Even maybe Jay. Jay, can you hand solder a BGA part? Okay, me neither. It's probably possible, but there's no way I can do it, right? Even with hot air and the stencil, there's no way. It could be well beyond me. But if for the times when we're trying to make commodity components and make them accessible at a reasonable cost, Mary Elizabeth, you're 100% right, and I know that was the goal on Project Vive, and I totally get it. I am of a mixed mind at this point. I have had devices that we didn't make because it was going to cost $35 to make them that never got made. And the volume would have been 5 people who asked for it. But it bothers me that those 5 people never got made because we were focused on the fact that it's going to cost us $35 in bill of material, and we don't want to have $200 devices, right? Or hell, if the BOM is $200 and we'd have to charge $600 or $700, we haven't made them. And there have been things that we left on the table for people because of that. So that's the other side of that. And listen, guys, I don't know. I don't know the answer to this. And Jay's in a very different space. Just so you guys know, Jay hasn't, I don't think, Jay, that you've been as vocal on the board, but Jay makes boards, he makes devices for power chairs, right? And he sells them to Medicaid and CMS at Medicaid and CMS prices, right? With liability insurance and everything we talked about on the last chat. So I'm not sure where our stand is. My stand, where I stand personally, I think most of you know, I think that this industry is broken and needs to be shaken, right? And I'm happy to do the shaking. But from where the charity's goal is, to me, it's about access. It's about getting the custom devices that are made to the people who need them. And honestly, I'm starting to not care what the price is.
Okay, so I just want to interject here.
Sure.
So you kind of said, like, you know, how you're saying it's so expensive, we're not, you know, not able, we decided not to make it. The truth is that Project Vive made so many one-offs, customized, but we wanted our budget to reach larger and really be able to make it accessible, like you said. And that's why you go to production, because all of a sudden, when you're buying in bulk, all those prices go down. When you're doing multiple circuit boards, all those prices go down. And and also it's a more robust circuit board, right? Like versus you hand wiring things, trying to, you know, make it. And especially if, you know, you're not an expert at soldering, which, you know, happens. You wire it up and it works. And you're like, oh, great, let's get it in the field. But then all of a sudden it's shaking around on their wheelchair. It's being banged. It's
in an environment that's got
right.
It's got an EMI that you never thought about, right?
Right. And so that's where also that production piece comes in. So anyway.
Here's an idea. I like to jump in. Like we pretty much always go for the throat and go straight to a production product because we produce production products. But I have always been fond of what you're doing, Bill. And you know, one of the things that comes to mind, and similar to what Mary Elizabeth was saying, is, you know, perhaps instead of going to, you know, the off-the-shelf boards and then creating the things from them, perhaps we build a population of AT specific boards that are really what the AT industry needs, that are modular, you know, sort of like the off-the-shelf boards for development, but basically dial it into a production off-the-shelf board for development specifically for AT. And I don't really know what that means, but, you know, switch controls, iPad interface devices, joysticks, things like that come to mind, you know, sensors, and maybe we define what that population can be and basically develop a product line of AT specific devices, and it could become its own thing, but maybe there's a direction we can look at just for an idea.
So I think
but I gotta weigh in here.
Sure.
On this. Yeah, I mean, we like a lot of us. I'm an Adafruit fan, and the idea that we can make a feather wing, or we can make a board that you can solder a Cutie pie to, I think gives us so many options. It prevents us from falling behind technologically. I mean, if we were having this conversation 5 years ago, we would have built a custom AT board with a 32U4 on it. You know, it would have been Arduino Leonardo compatible, and we would have missed the whole M0, M4, and RF wave.
MD21 and all the others, right?
51, NRFs,
RP2040, right?
And God knows ESP32, S2s, all of that. You know, by going with the feather wing format, we've insulated ourselves from becoming obsolete.
Right.
And we could go out right now and design a board that had an M0 or an M4 processor in it, you know, 7021, 7051, something, even an NRF board if we had to, and build AT products around it. But how long is that going to last? What's going to come out? I mean, Lamore is already talking about building a Linux board in feather format.
Yep.
You know, what's coming around the corner?
Chris, I was going to say it's worse than you think, because I just bought the last 2032 U4s that you can buy before 2023. So I hate to tell you this.
Yeah, that's right. You're also at the mercy of the chip shortage. All of a sudden, you're Ford and you can't ship any cars, right?
Yeah.
Right. That's a thought too. So
anyway, the idea of of making a custom board that everybody could use and we can latch on to it. That's not a bad idea, but I really think, feather took off. I mean, everybody is making feathers. Proton makes them.
Yep.
Spark Fun makes
Yep.
feathers. That's Adafruit's number one competitor to the extent that they do compete.
Yeah.
And it's really surpassed the old Arduino Uno big board, and even the new maker boards that
they didn't take off because of it. Right.
Arduino has its own somewhat feather shaped, but not at all feather compatible line of boards, and they're just nobody's. I mean, people are buying them, but nobody's building wings to go with them, and so I really think we need to keep that as a consideration.
Yeah. So we have a comment from Paul. So hold on a second, Jay. We have a comment from Paul Hewitt. He's talking about if we're making wings and things. It says wings and things. It's a restaurant I used to eat at, but you always get you also get the benefits of the lowered costs of the feather through economies of scale with it being used elsewhere than just AT. In other words, Adafruit is getting the benefit of the economies of scale and all the testing from all the other industries that we're not doing. And really, the microcontroller part's the part that we aren't adequately trained to do the testing and things like that, right? And they are. Jay, go ahead.
Well, I was going to say that there's a couple issues with like the feathers, and I love feathers. I do all my art development and prototyping on them. I think they're great boards.
Yep.
But if you're going to make 100 of something, it's actually pretty hard to get 100 feathers from Adafruit, just because they don't do that large a production run. And then the other part of that rapid progress that Chris talks about is, the feather you worked with 6 months ago might not be shipping today.
So
there's a new rev right out, and so from a supply chain and a kind of a production capacity, you can't really move a feather from prototyping into production effectively, is what I found.
So a couple things on that. I do like the fact that they don't discontinue their items. In fact, they were talking about it the other night. They do rev them, right? So they do fix bugs on them, and then you have to modify yours when they fix the bug. But it is fairly rare. They are of all the manufacturers, they seem to have a very long tail on how long they'll keep their products in development. If somebody's buying them, they'll continue to make them, right? But you're right that they do make revisions to them. I think one thought here, and I know I didn't put myself up. I'm sorry. That doesn't do it automatically. So, one thought I'd like to throw out, and it kind of combines things and kind of says where I am. I think we need to be thinking about both of these drivers, and we have to remember something else. And Jay and Glenn, this is mainly aimed at you two, not. This is just good for you to hear because you're commercial providers, right? Our designs, I can't say this sentence. Our designs have licensing that allows you to make commercial versions of them and sell them. You have to give credit to us for the original design, but not for your modifications. And we should be encouraging people to make and sell our products. And to take the ideas that we put in place. Remember, the goal is to make these things available. And Glenn, if you want to make a product based off of any of our designs, do it. We'll even help you. We'll assign somebody to help you with the debugging of it. But I think it kind of makes sense to say, let's start with the brain of our board on something that we're buying. So either a Cutie Pie, a trinket, a feather. But when we're making the other piece, when we're making the wing, the component that's going onto it that's AT specific, let's use some more intelligence on doing that part well. In other words, on those, let's have a library of parts. Let's have some guidelines on trace widths, which I'm guessing at and don't know, right? Let's have the ability to have people in the group. I have a design that I love that I showed you, and it's somewhere here, right here. That I thought of something really stupid I should have done. I had spare pins, and I didn't wire a spare GPIO pin from over here to the reset pin over here. So I can't reset the stupid daughter board. Another person would have seen it if they had reviewed this design. I promise, because the minute I stared at it in person, the minute I held it in my hand and I had assembled it, I knew I had made a mistake, and it hadn't been reviewed by anybody. Nobody's eyes but mine had been on it, right? We can do things that we would do if we were in production, but we're, again, AT Makers as a group and AT Makers as a charity isn't in the business of selling any of this, right? We're designing this and we're trying to get this made. Most of the things that we make, I give away. I would say, God, everything. I'm having a hard time finding things that were bought. The Freedom Wing is the only thing I can think of mine that people have bought, and they haven't bought it from me. They bought it from PCB houses that have assembled it for them, or other individuals who've assembled it for them, and they've paid them for it. But
well, if you go back to our discussion from a week or so ago,
yeah,
we can't sell.
We can't. Well, let's be clear. We can't sell things that are used in mobility and high-risk devices. We can sell them. We have to do the risk analysis on them.
Yeah. Well.
Yeah.
Yeah.
That's the truth, right? That's where we ended up. It's certainly true.
Well, I came away from it. I thought you said that
there's a different risk between giving things and selling things.
Okay.
Where I drew my absolute line is we can't ever sell things for mobility, and to be honest, we can't give things away for mobility.
Yeah. But I thought you were saying that we couldn't sell things.
What I was telling Malad, and I'll say it again, and I've said it to Jay, I think, in an email since then. Malad was asking about putting the things that he built on Tindy and selling them. And my argument was, if you are giving them away, you're now dealing with strict liability. It's a much higher standard, and you better have done the risk assessments and the labeling and the warnings, or you're going to be at much higher risk. If you're giving it away, you're held to a negligence standard, which is what you did reasonable? Yes, like almost certainly the answer to that. If it's not in a dangerous situation, will be yes on these. So that is the takeaway. It doesn't mean that they can't be sold. Glenn, for example, and I'm sorry to use you as an example, but you joined the chat. Glenn could absolutely take our devices, manufacture them, and sell them because he's got other product lines and he already has capital to buy the liability insurance in order to do that. Right? Right, Chris?
Yeah, I understand. What I was saying, we can't sell it. I meant AT Makers can't sell things unless we get liability insurance. That was my takeaway.
So
if I'm wrong,
today, that is true today. So that is the charity's decision today.
Let me know. Let me know if you guys want to. I mean, we pay liability insurance based on our annual sales, so anything we make can fold into it. And I mean, I'd be happy to entertain that as a concept. Just because. I mean, I can.
Yeah, you should. So, Glenn, before you go down that road, I seriously, when we get done with this or tomorrow, the last one of these chats that we had, it's on the Facebook group. You should absolutely watch it and then call me. Or you're here in Sarasota now. We can actually get together. But
we got to get together.
Yes, but watch that first because it was these same players. Everybody who is here is also on the talk about risk assessments. And I'd love to hear your
send me a link. I'll look at. I'll check it out.
I'll send you a link. In fact, I will post it to the comments here now. There's no point in waiting because I'll forget. because that's, let's see, AT makers, risk assessment. Right. Don't start playing. Don't start playing. It's going to start playing. All right. Yeah, I know. Okay. Sorry.
You just delegated that one, Bill.
No, it's all right. I should have delegated that one. Is that what you said? Yeah. All right. Well,
You're the chat moderator.
but this. So if anybody thinks that I'm paying attention to video quality on this one, they're wrong. Okay, that's not the goal. In fact, we should probably get back to the goal. We are on a tangent that started when I said, do we think we're mainly going to make boards that are daughter boards and accessory boards? And the answer sounds like maybe not. But let's also start with this. We will be making boards that have these on top of it, right? Go ahead, Jay.
So
You never have to raise your hand. Just step over me.
yeah. So one of the things that I learned when I started trying to make hundreds of medical devices, we use a kind of a high-end manufacturer because that's part of that risk analysis that you talk about.
Mm-hmm.
One of them is you use a really high-quality manufacturer. And then what I learned really quickly was that through-hole components,
Mm-hmm.
they start off more expensive because they take a lot more effort to produce, but they're also a lot less reliable. So, for example, the failure rate of assembled boards that have through-hole components are probably 10 times as high as those that don't, and a lot of times you can't get away from it entirely, like your USB connectors or your various things. They have to be through.
To be clear, it sounded like you said two different things there. I agree with your second point. You're saying that the through-hole connectors are far more likely to fail than the surface mount. Absolutely true.
And it's also much more expensive to assemble.
Yeah, because you can't pick and place most of them.
Right. And so a lot of these designs, you do yourself a favor if you can design them to minimize the number of through-hole components that you have, both from a quality and a cost
Correct.
perspective.
The flip side of this, though, is the name of this group is AT Makers, right?
Yeah.
So the minute you're going to an 0804 or whatever, 0806 or 0804, whatever resistor, the robotics team start rebelling. Okay. Yeah. There's no way they're going to be able to do that.
Of course.
So there's the flip side of what we're trying to do. I like the idea of saying, for example, I don't know, this board that's the solid state relay board, right? Yeah, we just have this assembled. You swap out the jacks are going to be through hole, but shit, sorry, not family friendly anymore. So, but yeah, so the jacks are through hole, but you can get rid of those, and the resistors and the SSR surface mount. But get these things made and assembled, and assembling these into a solution is absolutely something that the makers can do, right? And you make sure that you have the combination of the things that are commodities and we're making a ton of. Yeah, get them done surface mount, get them done assembled by a fab house. But the actual assembly of the solution, right, needs to be in the hand. It needs to be possible by the people who are in our community. Our goal has never been free or cheap AT devices, right? The goal, if you look at the charity, is to bring together the people in the maker community with those in the AT community who really need their help, right? The maker community lives on PTH, on through-hole soldering, right? It's what we can all do it, and through-hole soldering, I'm including castellated pads. They're easier than there's half the number of joints to hey Joe, how are you? It's half the number of joints. It's one side instead of two. It's all better. But that kind of simple soldering is the free labor that we can provide to the AT users by getting the makers involved, right? So we can't forget that part. right?
Well, and the other thing is, we've got kind of, I think in a meeting we had some time ago, we came to the conclusion that we sort of have two levels of products that we're
Mhm.
developing. And the Freedom Wing is the prime example. You know, we designed the Freedom Wing. It's full of through-hole parts and things. The kids can assemble it. We put it out there, and it was a hit.
Yep.
Okay,
Yep.
and so now that it's proven to have a market, so to speak, and that there's a massive need. You know that we need more than 20 of them.
Right.
Yeah, we made hundreds.
Yep.
Now we need either the version little itsy bitsy one that Dimitri made,
Yep.
or we need a feather format that's surface bound.
Let me go grab one while you
And-
finish that thought, so I can
and,
show that difference. It's a good example.
You know, so that's the kind of thing that we would put into production. And at that point, then yeah, we need all the surface mount we can get. We need to be able to send it to some fab house and say, "Here, just make me a ton of these." And so we've really got two different levels of work that we're working on. One is these prototypes that we make more than what you normally think of a prototype. So we might make 50 or 100 of these, or 200. But at some point, once we get to that kind of volume, then we need to redesign and really make a production version. But we can't. It's not a case of we're either going to have only through holes that makers can do, or we're only going to have production products. We're having these two different levels, and we have to straddle those two different levels really at all times. And even once the Freedom Wing would go into a production environment where it was all surface mount and we were getting it made at a fab house, there's still going to be people that are going to want that old version to tinker with and to maybe modify or to add something to. So we've got to serve the users and the makers both, because that's what we are. We're a marriage of the makers and the users.
Yeah, absolutely. Let me show this for a second here, Chris. So just to make his point, he's got exactly the right point, and I could hear you the whole time. I just had to step over to the other workbench. So this is the Freedom Wing that I made. Okay, it's got a Pololu 12-volt step-up converter. It's got a couple of diodes, a reset button, headers. This one has double headers because Chris O'Dowd screwed up when he made it. But I didn't say that. It has this 9-pin plated through hole jack and 6 through hole resistors. Okay. And this is the hit. This is the thing that was the hit. People would pop this on top of pop a feather on top of this. I won't bother doing that. You know what that looks like. And this will take the joystick from your power chair and get it into. I will go ahead and do it. Oh, here's a version that's already got it in there, right? So you put the feather on top, and now you've got a joystick input, a 9-pin input, and if you want it to be a USB mouse, it's a USB mouse. Chris has flown a drone with it through the Bluetooth chip here. We've done a ton of things with this board because the AT users have the 9-pin joystick that's been adapted really well for them, right? Dmitry Votanchev at Google took my design and said, "Hey, this is a really good idea, but wow, you made this inefficiently." And he made this, right? So this is an identical board. It's got the same jack on the end, right? This is actually an edge set board, which I actually do think has to be hand soldered. I don't think it can be flow soldered or selective soldered. Maybe if you did it first, but I don't think so. I think this is hand soldered. But even if it's hand soldered, it's it's 10 solder points that are super easy and easy to assembly house would have no problem, and everything else on it is pick and placed. Right? Turns out he did these by hand, which just freaked me out that he could do these by hand, because those are real. That's this guy. There's a little resistor right in here. That's crazy that he could solder that by hand, but he did. And so he made this, and he made it for $6. And even this whole thing here runs around 12 plus the feather. The output of it is a SparkFun quick connector or a Stemma QT connector. So he can take any of these boards that I was showing that have the Stemma QT connector on it, wire it up to this, pop it out the side of a assembly unit, and there's no soldering. You just have a jack that if you put this in your design, you now have a I2C input for that input that goes into your controller. So it is exactly the process that Chris was saying. We made this. We proved that the design worked, right? We proved that there's a demand. And then Dimitri took this and turned it into something that is a component that could be put together. And his project Mimosa, that's kind of the goal of it, is to make these plug and play components that we can make. He actually texted me today saying he wanted to chat about new stuff with Mimosa. But it's definitely, I think Chris is right. There is a really good argument that we are not one or the other on these things. We sit in a space that we can provide the prototyping, the testing. We have the users. In fact, we have this super rare thing, Jay, that your smile here is going to. I know it's coming. I always like that, right? And we lost Glenn somewhere.
He said he had to go, but keep him in the loop.
Okay. We have people like Chris Young, right? We have users that are makers that are designing this stuff, right? Like that's like the most useful thing if you're making these products is people who can give you intelligent feedback and use your product, right?
So there's actually, I have one goal for tonight, personally.
Yeah.
And that is to see like this larger community. I'm wondering if we can use things like these PCBA houses to make something closer to that second board that you're just showing sooner in the process. I've struggled and I can't yet because I'm using a high-end house or manufacturer, and so like it cost me like $30,000 to do 200 boards, and it cost me $15,000 to make 5 boards.
Right.
So
you can't do it with that. Yeah.
You can't do it, and I mean that's not a way to prototype. And just like everybody said, right, we all need to do 5 to 10 revisions of something,
right,
to get it right.
Yeah.
So is there an intermediate that we can kind of move towards that kind of gets us a little further along? And if there is, when we talk about like doing Eagle and some of these designs, can we select kind of a process and a tooling that enables that kind of intermediate, kind of that PCBA house, right? Approach.
And to be fair, remember I said the very first board I ever made in Eagle was that, right?
Yeah,
it was this.
Exactly.
Right. And it went to PCB way assembly. So it went to PCB way for assembly. So they made the board, they bought the parts, they did the assembly, they did a test run first. They had them. I had an error and they had an error, right? So my error caused their error, but that wasn't. It was very easy, back and forth. I sent them a revision. They actually fixed the 3 boards that they made so that nothing was thrown away, and they came out even at quantity 20. This board cost me $35 per board, with no upfront tooling charge. That's all just rolled into the cost, right? So yes, that absolutely exists. And that is exactly the in-between that you're talking about, right? We should use it more. We should get to it more. And Jay is, John Jordan is like, yeah, because he was the one who kept saying this, right? Paul is kind of, I'm sorry, Paul, I haven't been reading what you've been saying. but yeah, it's about proving demand. It's an important first step. It's also about proving the design, right? And this says that's John Jordan says my last PCBWay assembly from DigiKey Parts was $200 for 13 boards, right, for the assembly. So there is no doubt that in between exists, and it is in the maker world. And what's exciting is that ignore AT for a minute. Like the maker world recognizes this, and like everybody's getting boards made. Everybody realizes that wiring boards is dumb, right? Like even really small projects that need 10 boards, you're almost better off. I don't know about the assembly, but certainly you're better off getting the board made than doing any wiring. So I think some of that, what you were just talking about, Jay, exists both in the maker community and in the AT maker community. Part of what's driven this particular conversation, not the one we've kind of sidetracked here, but the one that started this conversation. Oh, sorry, Jay. John Jordan, give me another one here. Right, this was we were talking about earlier. Is the fact that Malad Ha, Paul Hewitt, Jake MacGyver, Dmitry Votanchev, Mary Elizabeth, me, Charlie Danger, Chris Young, John Jordan, I might have already said him. Let's say there's 10 of us who have all come to the same conclusion that we need to be making these boards rather than giving instructions on how to wire things. And we're all making them. So let me show something. Let me show in GitHub. I know. So Mary Elizabeth, did I stop you from jumping in? Because you're laughing.
No, I was just commenting that's a very it's interesting conclusion.
You think I was wrong?
No, I don't.
Okay, good. All right, so you guys can't see my screen because I suck. Sorry. This is again bad design. So this is the Mimosa project, which you all should know about. I'll post it in the chat here. This is Dimitri's project, and it talks about what his goals are: the pluggable stemma-based modules for AT use, which I think is brilliant, right? So like if you're not going to make feather wings, make stemma QT and quick components. I think it's great. That's not what I was going to GitHub for. If I go to GitHub, by the way, you all should join. If you're on GitHub, you should join the AT Makers org. I'll be happy to approve you because you seem decent. But Milador. So users. His name is Milador. No, here. So Malad Ha is an engineer in Canada, also an AT user, just like you would, just like Chris. He's in the same league with Ian Price and Chris and others who make their own AT. He works for Makers Making Change, and he's got controllers and other components here that. Right, this is it in a box, but in there is a PCB way. It is a PCB that he's made because he's come to the same conclusion. You'll see this one's got a bunch of jacks. It takes itsy bitsy. I think that's an itsy bitsy, and then it has LEDs for instruction and signaling. And he had it made, and he has it. That's it assembled. Right. It's actually it's kind of cool. It's probably. Like if I made it, it would look exactly like this. I like that. I always like when things like happen when I'm not there, just like they would if I was there, and that kind of fun, right? But again, look, there's an itsy bitsy from Adafruit, 2 stemma boards or other Adafruit boards that he's using, I2S microphone and another I2S. So he's got a stereo microphone or something. So he's doing that same thing. If you look at Makers Making Change, which I just saw a link to, so I'll just jump to that. Makers Making Change is our equivalent. Chad Lehman is the director, or I think he's director on that. They have the lip sync, which again is moving to much more PCB. There's much less wiring in their new design. And again, it's holding down smart boards on top of it. So if you look in the hardware section, the new PCB design is in here. And again, they're doing this based on the boards that they pop into these. I'm not going to bother going into these, but the board that they're placing into these are Adafruit boards as well. Okay. So what we ended up with was we all are doing this. Rather than getting back to the question whether I asked, are we all going to focus on this? Because we're all doing this, at least, let's stop being stupid and doing it all every time from scratch by measuring the stupid boards, right? So I happen to be, let me bring this up since I'm here now. This is, nope, that's just me. There you go. So this is a design that, this is what I really want to do for things like the IntelliKeys, right? I really want to have a board that that looks like this, and it has a USB, a male USB on one side, and a female USB, male USB A on one side, a female USB A on the other, and you can plug in any ancient any ancient USB device that has a weird ass protocol, plug it into this, and on the other side you've got a male USB A that you plug into your computer, right? And that's all this is wiring. But with the work that we're doing with USB host, this is just going to work because the RP2040 is going to have both a USB device and a USB host, and both Arduino and CircuitPython between it to write the logic we need to convert the protocols. So we will be able to take one of these. Okay, so this is a castellated board called the KB2040. They call it a keybore. And it has an RP2040 chip. It does have a stemma QT. We're not going to use that. It has a USB-C device, but you'll notice a couple things. It pulls out the D plus and D minus. And then the way this is written, you can use PIO to give you the USB input, the USB host mode, right? So this is my current project. Looks like this. And I can do Red's Nest. Looks like that, actually. This is the kind of stuff where if we take their brains, all we're doing is changing the interface points on it, and it's enormous, right? So what do I need to make this happen? Well, I need the ability to drop a KB2040 onto this board without having to measure and space things by hand and get them wrong. I have to have the components for the the USB components. If you look at this guy, which will pop open, there are times when I need multiple Adafruit boards on them, along with jacks. We all use the same jacks. We should have a library that has the damn jack in it, so we're not all trying to find them and download them and import them and everything else. And so here's the one that you guys actually saw physically. Right, it's got the trinket over here and the Cutie pie over there. Well, I should be able to go in the schematic, hit plus, go to AT Makers, say I need a Cutie pie, and tell it I want one for through hole. I want one for through hole without the extra pins. I want one for castellated pads. And then this one's for at the edge. So when it's on the edge of a board, I want multiple footprints for each one of these things so that when I add it to my project, I'm not doing any measuring. I'm just dropping this part here and it's just going to work. Right. So we need to come together and make one set of these. Like let's just start with that. Does everybody agree that this would be handy? Yes.
The problem is, I don't know how interoperable all of these PCB design tools are.
Right.
You're making an EagleCAD library,
right?
And you and I think, we're the only people here tonight that are using Eagle.
Well, so it's interesting. The response I got, Chris, when I asked this question, everybody said the same thing. They all said X and Eagle, right? All of them said X and Eagle. They said Altium and Eagle, and they said KiCad and Eagle. So what I would recommend doing is saying, there are tools that convert Eagle to KiCad. I don't know if they're for parts libraries, not for full board files, but for parts libraries they do. I don't know if that's true for Altium or not. I kind of think it probably is, but if nothing else, Eagle's an SVG text format. We can write something if we really, really have to. But what I'd like to know is if there's people who are going to use Altium and think that's going to be valuable, then let's ask them to contribute, not by making parts, but by converting, right? Because the reason that I started an Eagle is that's where the Adafruit parts are. So I don't know if you guys know this. I know some of you don't know that, or some of the people watching don't know this. Paul Hewitt doesn't know this, right? I don't know. Maybe that's not true. If you look at any board on Adafruit, and you go here to where it says downloads. So I'm in the guide. I'm in the guide for a part. So if you
We don't see
Can't see your screen.
oh, thank you guys. I'm so you guys are so much better. Like everybody else I work with doesn't do that. They just let me talk and talk and talk. So yay, thank you. If you're looking at a part that you're about to buy, you'll be sitting here saying, "Hey, it's $8.95, right? Or I'm going to buy 100. It's $7." At the bottom of it, there's always a link somewhere in here that says, "Check it out in the product guide," right here under Learn, right? In the product guide, the last thing always says downloads. And here, there's their schematic, which first of all, you can learn so much by starting with Lamore Freed's designs and just figuring out how she's doing power management, figuring out how she's doing her USB management. You can learn an absolute ton here. There's the design print, and then there's the CAD file that they generate. But more importantly, if you click right here, it'll always say EagleCAD PCB files on GitHub. They're open source, and literally you can just download the board, the schematic, the file, and then the under assets. These you can actually ignore them. They're just actually the things like the pictures that are used here, but they're there to start from. So you never have to get a physical board and start measuring it. You've got the design. You can open it up in Eagle and do it. And Eagle's free to start. Like everything I've ever done has been in the free version of Eagle. I have AT Makers has a relationship with Autodesk where I can get, they've invited me to join this group where we can get full versions of things if we want them. Fusion, I might do that because there are some limitations on the free version of Fusion that drive me a little bit bonkers. But I really can't see me using the features that are in the pay version of Eagle. There's no commercial limitation or non-commercial limitation on the free version of Eagle. So you can use it.
Yeah, I think the restriction is the overall size of the board, which the things we're making are relatively small and they easily fit in the size restriction. And then no more than double layer.
Right. So you have two. There's a third.
I don't know any of us that are smart enough to make more than a double layer board. Anyway,
So to be honest, I would, if it was like free, I would always just do 4-layer boards with ground and power in the middle because the life would get much simpler for layouts, right? But you're right. And other than that, I can't imagine wanting it. And certainly you can solve it. It's not an issue. The third restriction is stupid. You can't move parts outside of the boundaries of the board. Like if you just want to move things around while you're like making space and moving things, they don't let you. It's just a stupid restriction on the free version. And you can totally get around that. Just be frustrated every time it pops up the little window and yells at you. But yeah, those are the only things. So you can find these boards with everything that they make. And that's not like just the microcontrollers. Every sensor they make, everything that they make, they publish these PCB files so that if you want to make something that holds a sensor, which you saw Malad do, it's there. In fact, if you want to take their design for a sensor and just change out a component or have it have 2 of them on the board, you can just start with theirs and move crap around, and it's legal, which is cool, right? Because all these things are licensed either Creative Commons share alike, like for this text, and then for the actual design, I believe it's the MIT license, view license. So yeah, this is so it's Creative Commons. So it's Creative Commons share alike for both. So all it really means is you can't, if you modify it and ship it, you've got to share your designs too, which we don't care. We're always sharing our designs. That's the point, right? And if somebody wants to be closed and not share their designs, they can still take the idea. We've proven the idea. We've proven the design. But we're not patenting it, and we've proven the demand. Even if you end up having to make your own board, we've done a colossal amount of work for them. We are. Paul Hewitt is turning into a pumpkin. I'm glad you will watch the rest, Paul. Thank you for starting this conversation. We haven't made progress in the directions that were on my list, but I actually think this kind of chat is, when we don't have this kind of chat, just so you guys know, I struggle with these things with Jonathan and Chris and Eric about, are we moving this thing in the right direction? And there are days when the answer screams yes, right? When I go to help Ella, and she was not going to get the help she needed for months, okay, maybe ever, okay? When I see the video of the remote control car that the guy made with the adaptive controller, and it's got a freaking Freedom Wing there, and I didn't make it. I've never heard of the guy. I love it when people are doing this and I'm not involved, right? It's wonderful. And then somebody sends an email about, I've gotten more than one cease and desist. I've gotten more than one patent infringement letter. It's like, screw you guys. But when we have these conversations, like the risk assessments, sorry, Mary Elizabeth, I keep making you laugh, but it makes me very happy to have other people in these conversations. Okay. I would like everybody who does this stuff to be more involved in these weekly, quarterly, I don't care how often, conversations. By the way, John Jordan says he used the paid version of Eagle, and when he uses it for when it's over 100 by 100 millimeters, so which is plenty big for most of the things that we're making. In fact, I can't think of something I've made that was more than that. It says, for the library, we need a channel for members to request parts to be added to the library. Let's get tactical for a minute. Let's actually accomplish something with this meeting. So, yes, you're right, John, and thank you for moving us in the right direction. So sorry. I wish I could disable that layout, because it's never the right layout. So I did, before we started this, I thought about how I would like to see this work, and I have an idea. Okay. I think we should have a repository on GitHub for AT device libraries. These are PCB designs for common AT devices. And I think what I would start with on this is probably to enable the wiki tool, but just, I would like to have a few things that you could go to this repository and get. First, because of the way Adafruit's designs are licensed, we should be able to make board footprints for all of the Adafruit components that we use, put them in a library that you can just download. Because if you look at their component library, isn't footprints, right? It's all the things that are on their boards, right? Adafruit's library inside of Adafruit has a library inside of Eagle, right? So if you're in a schematic and you go to add a part, there is an Adafruit library, and it's actually, I think it's standard now with Eagle. It ships with it, but if not, you can download it. The latest is always up in GitHub. But these are all free, copyright free, because these are all public domain footprints that are either done by Kevin Townsend or Lamore Freed, that we can use. And these are the parts that they use, right? So they've made sure that they have the rights to distribute them. They're in here, but these aren't the Adafruit parts. In fact, the only Adafruit part that I can think of in here is the feather, because for the feather, they made a feather footprint, okay? So if I add this over here and I go to the board view, it's got a feather footprint right here, right? That is what I want for all the other boards. They don't make them. And to be honest, I'm not going to ask them to make it. They're doing an absolute ton for us. I have told them about this chat. That's why the GitHub thing was open. If anybody from there would like to help with this, we'd love your help. But this shouldn't be their job to make footprints of all their boards to make it easy for us to make our boards. I mean, but this is a great example to show, how did they do it, right? What works well, and what limitations can we expect? A good example of it is these warnings, right? So I don't know if you guys can see this well, but you see all these little warnings here. Those just mean that these holes are too close to that cut line. And it's okay because it's inside their part. They've done the testing. They know it's there. But when you go through your design review, you're going to have to actually approve all those dimension issues once and say approve a bunch of times. The fact that Lamore did it that way and she couldn't get rid of those warnings means that when I make one and I can't get rid of those warnings, I should be okay with it, right? And we should be aware of it. So what I would like people to be able to do would be to go to this repository and have in either this README file or the wiki a list of all the parts we use, like the Adafruit parts, the DigiKey jacks, the USB jacks, all of the things that we use a ton of, the relays, and we should have basically several columns. So one is there a version of this footprint in our library? And if there is, great. You download our library and it's there, and that's fabulous. And if there isn't, where can you get a footprint? So a lot of times the answer is Ultra Librarian or DigiKey has it, or here's a link to CUI, the manufacturer, where you can download theirs, or it's already in one of the other libraries. We found it. We know where it is, because I don't think we should create every part when they already exist. And I know we can't distribute all of the ones that the manufacturers distribute because they're copywritten and you can't do that, right? So if you look in Eagle at parts, I don't even know how to do this. If you look in Eagle at the parts manager, John Jordan's rolling his eyes at me right now. If you look at this, this is an SSR that I used. I got it out of Ultra Librarian. If you open it up, you will see it says copyright right here. It says, you can't see. Really? You're going to let me go without telling me this time? Mary Elizabeth, you're fired. So if you look at this part right here, how long were you not able to see?
Not long.
Not
Okay.
long at all. Like, I thought you were really just telling me what it was. But
Okay, no. So in the parts library here, you'll see that this part, which I've added into my library, is copyright 2022 by Ultra Librarian, all rights reserved. It tells you where the DigiKey part number is and things like that. Well, I don't want to remake this part, right? That's a ton of work, and I don't want to ask anybody in our group to go through that hassle. But I want people to be able to find these parts easily without having to make them themselves. So to me, having some kind of essentially a spreadsheet, basically a table that says by group, okay, here are all the switch jacks that we use. And I use 3. I've tried to get it down to 3. They're all, 1/8 inch or 3.5 millimeter jacks. In this case, these are all PCB boards. Let's get them in here and say, here's where you get the parts for each of these. And then for the ones that don't exist, and the biggest bunch that doesn't exist right now are the Adafruit Footprints. we've got one. We've got a library that literally might just say Adafruit Footprints or AT Makers Footprints or something like that, that we make available in this repository. People can just add it, and they've already got the daughter boards, and we don't all have to make these ourselves. And for all the other stuff that's common, it's also a place for people to have a conversation and say, what switches are you using, right? Because you go in here and you open an issue. There's a thing in here called discussions. Did they disable those? I think it's something you can turn on called discussions. Maybe not. I'll go through and see. If not, there's issues. People could open issues and say, hey, can we add this, this jack? Does anybody know where I can get the footprint for it? Because we're all doing the same work.
Oh, you mean issues up to the top right on the right side of code?
Yeah, so issues is always there. There was an optional thing called discussions. And maybe the answer is they got rid of it. Discussions right here. So I'll turn it on. Okay, so I turn this on. Then when I hit save, there's going to be a save somewhere. There's no save. All right, so when I go back and reload this, maybe. There you go. So discussions, right? So this is a place where you can have this. It's not a complaint. It's not an issue. It's not an enhancement request. It just is a place to talk about, hey, I found this cool new part. I think it works great. Here's why. And by the way, I found this Eagle part for library that has it in it. Or can somebody help me make a part for this? Does that make sense?
Is there a way to pin to the top? I've never seen this discussion feature. I use GitHub a lot, but now.
Yeah, so they added it about a year ago. And so yeah, you go in here, you hit new discussion. You'll get notified if somebody comments on the discussion like here. So
just because my biggest thing is vetting what people, because if you have everyone, like I said before, posting all these designs that you're not even sure if they work, but ones that certain people can say, hey, I did try this, it does work, right. So that they can quickly sort through and get what they need, instead of it just being a Tower of Babel.
Yeah. So
I got a red bill.
Okay, Chris.
So
okay.
It's been a pleasure as always.
Yeah, we'll wrap quickly. We've gone longer than I wanted to.
Great to talk to you, Chris.
Yeah, good to see all of you.
Oh, by the way, Chris is going to join me at the Patents Tech Expo in April. So if you're in Indianapolis, you can come see us both. So, bye, Chris.
Bye.
Great to talk to you.
Yep.
So Mary Elizabeth, I understand your concern.
Yeah,
right?
We don't have to talk about the discussion. You can go on with your stuff.
Yeah. So I think the idea here would be, don't do this as opening it up. Sorry, don't do this as opening it up to everybody in AT Makers can edit this thing. Use the pull request process, right? And use the issues for people to make requests. Use the discussions if we want to for broader discussions about asking questions about what's a good part for this or things like that. And I'm all for trying that out. And if it doesn't work, hell, this might not be the right platform for the discussion part, right? The discussion part might be a Discord server. It might be on the Facebook group, right? Whatever we need to get to. But have something that says, we've got parts that one of the 10 of us, 12 of us, whoever it is, has physically made the device and tested it, or is currently in production of it. We have some kind of a process that can ask, hey, can somebody review this design before I send it off to PCBWay or JCL, right, or wherever else it is that we're going to send it, to request a review. So GitHub has a review process, right, for pull requests, right? We can use that. Can we do something that says, we have a little bit of structure around managing something that is valuable, two things that are valuable, a directory of parts that we use for our devices, and a library of parts that nobody else has, right? I think that would be very valuable to me, right? Whether it's valuable to everybody else, I have no idea. But I was asked by Jay to talk about this. So John Jordan says, for the library, we need a channel for members to request parts to be added to the library. For example, he says he has Itsy Bitsy and the quick SMT connector. Kanban was missing too. So yeah, so the GitHub has a Kanban feature as well for managing tasks and assigning tasks to team members.
We're going down the rabbit hole.
I know, right? I'm not suggesting I'm gonna be using Kanban. That's beyond me. I don't get paid enough for that. Okay.
Mary Elizabeth's in charge.
Yeah, Mary Elizabeth, you're running the Kanban. We're gonna send you to Tokyo for some training. But yeah, there probably is one in here. There's sponsorships so people can pay us. That's nice. Is there a Kanban in here? Maybe he was being facetious, but I think there is. Oh, it's called projects. I think they moved Kanban to Yeah, they did.
Is that mostly based on Microsoft project, which was that Gantt chart?
No. This is it's a Kanban approach. It really is. You make a project and you drag them between priorities and you assign them to users and stuff. But I don't think it's called Kanban anymore. I think once they went live with it, it's called projects. So it is here. But the other thing to remember is GitHub was bought by Microsoft, right? So anybody have thoughts on the value of this? Mary Elizabeth, you've rolled your eyes at me twice, and Joe laughs at me several times here.
Jay, why don't you comment first?
I'm curious what Eagle has in terms of parts libraries and parts library management features, because I think that's that's like a professional feature. So I think it's part of some of the tools. And I imagine Eagle probably has something like that.
So Eagle has a set of standard libraries that are updated when you update Eagle. It has a parts manager, which I was in a minute ago, that is right here. So within your library, you have a table of contents, and you can see the footprints and the symbols and stuff. When you're actually using this tool right here, basically there's a library manager that lets you
share your screen.
Really slow, guys, slow. So within the parts manager, you can see the devices that you're making, their footprints and the symbols, which is how they split things up. When you're using the schematic, there's a tool called the Library Manager, which shows you which libraries are available. So if you hit browse in the standard library from Eagle, there's a ton of them. These are all the ones that I've currently added. And so this is the managed folder. And you can add and remove these from your Eagle installation. You can add your own by just clicking and choosing a library, and then once you've done that once, all of your designs going forward will have access to the things in that library. If your library is updated, there's an option here that says update all, and it will actually go through and tell you with warnings which of your footprints have changed, which of your schematics have changed. What else? Oh, one neat thing is that if you're in the board view, like I don't have one open here. So if I'm in the board view of this and I decide I want to change this footprint right here, you can go to package and it will actually show you the other footprints available in all the libraries that match that symbol. So you can change, I want to go to a through hole instead of the surface pads. If you do that, it'll actually swap it in place for you. And the undo works, which is nice. So there is some real library management in it. It doesn't have the distribution part is not included in the free stuff. In other words, them updating your libraries as they have new parts is not built in. But the management of using libraries within the tool is built in. Does that answer your comment, Jay? Is that different from Altium? I haven't used Altium.
Oh, I don't. I don't know the tools well enough to say.
Okay. All right, Mary Elizabeth, now it's your turn to comment, given your smart aleck smirk earlier.
Well, I had a comment that
Sure, Joe.
I haven't been using this for a long time. Our company's hired other guys to do this kind of stuff. But early on, when I tried to use Eagle and that library feature, it was confusing and led to dead ends. And the fact that you're saying it's working better, that's encouraging.
So what I will tell you about the parts manager is it is not in the order in which you have to do things is not intuitive. In fact, it is exactly the opposite of what you would expect. In fact, probably the thing that helped me the most, I showed it earlier, but I'll send the link to it. One of these. There you go. So this guide right here that says K-Town's Ultimate Creating Parts in Eagle Tutorial, which I'll put a link right here. If I can. There you go. I know I should have delegated that. I'm sorry, Mary Elizabeth. But this guide was the only reason I got into making the parts. And it is backwards. In fact, what I will be happy to do, probably not with a live heckle gallery, or not with live hecklers, Mary Elizabeth. But what I will be happy to do is make a video for our group that says, all right, rather than reading this guide, here's a walkthrough of how to make a part. Like in fact, the next one I have to do is that KB2040. Let's walk through making a footprint for the KB2040 in Eagle. The weird thing about it is you go out of order. So you create a symbol that's empty, then you create the schematic, then you create the footprint, which are all unrelated to each other. They're not like inside of each other, which you'd expect. You make a symbol, then I'm going to give it the schematic, and then I'm going to give it you don't expect these to be separate parts that you then have to later go and tie back in together and assign which pads go to which schematic point, which schematic pads go to which board pads. You don't expect to have to do them in the order and to tie them together. But when you've done them, using them is then very simple, right? Using the parts that you've created is then works very well and lets you swap packages and even does nice things like, I don't know if you guys saw that I created two versions of the Cutie Pie footprint, one of which was for when you're near the edge of the board, which is going to be most of the time. It actually will add the dimension lines to cut out to cut this little strip thingy out. That's why I did it, was I couldn't figure out how to do it otherwise. But it means that I can make a footprint that if you're near the edge, use this one, it'll cut out the part for you. It works pretty well. You're right, Joe, that it is not intuitive, and the worst problem with it is if you go the wrong order, you can't fix it. Does that make sense? So yeah, which is not great, right? The good news with it is it does generate parts. I've never had PCBWay not be able to make the parts. The DRC, the design checks, their defaults are very conservative, so the design houses have no problem. You run the DRC, it tells you your traces are too close or whatever, and as long as you go through and either approve them because you know better or say, oh, okay, that's not going to work, the fab houses can make everything that I've ever sent them. In fact, I've got 3 coming in Thursday, I think, for some more of these parts. Also, I'm shocked that even today, with all the things going on in the world, I've got a 4-day turnaround on PCB parts from China, and the price is absurd. It's absurd. I think I paid $90 for 150 boards with a 4-day turnaround on 3 designs, which that's including shipping. It was under $100, and it's a 4-day turnaround. That's berserk, right? Yeah, she doesn't believe me. I'm going to show her.
You're just lucky the parts that you're using
Well,
because
they're not doing the assembly. They're just doing the PCB.
oh, okay.
Right. Yeah, no, that wouldn't work. No, I couldn't do that with assembly, right? Because they wouldn't be able to get the parts. But I'll show you I uploaded it. I think it's already shipped. So yeah, they're giving me kickbacks here. But yeah, so this shipment right here has I just want the picture here. So it's got this one, which is a pops on top of a cutie pie. It's got this one, which is the that host board that I talked about, but it doesn't have the male USB because I wasn't sure if I wanted to have that go into the side of a computer because it might not fit between the other plugs. So this one will actually have a USB-C plug, female jack. And then it's got the one that we talked about, which is this one that has the key built right into it, right? Like this one actually has the PCB version of it. I had to make it thicker. But yeah, they're going to be here for $93.20, including shipping, which is just berserk. It's like you can't afford to wire things because it literally costs you more to wire things than to get the PCB boards made. Right? If you put any dollar amount on your time whatsoever, we should stop wiring things. Right? Yep. Yes, Mary Elizabeth.
Yes, totally agree. Absolutely.
All right.
We're
Okay,
in our heads before you.
Yeah. So, all right. So, if we do this, are you guys interested? Will you participate in this?
Yes.
Yes.
Absolutely.
And Jay, would you help with this is YouTube? YouTube already has Eagle Parts Library videos. Okay. So that's John Jordan saying that. So Eagle does have a lot of YouTube videos about their parts library. And there are certainly ones that walk you through making parts in the right order. So I won't reproduce those. I'll make one specific about starting at an Adafruit board and pulling out the footprint and then making the part, getting it into the library, and getting it up into GitHub. Or at least I'll leave the last part out because people are going to bounce it around before it gets up. And truth is, I might put all of them into the library, or me and two other people who want to be librarians, right? Might do that. So John says, sign me up for parts creation. Excellent. And review, John. You have to sign up for review. That's not optional for you. Mary Elizabeth, you too. I do have a question before you go, Mary Elizabeth, while your dad's here. How are your preparations for med school?
Good. I'm trying to figure out how I'm going to pay for it at the moment. So having fun with that.
Yeah.
I haven't decided.
But you haven't decided yet?
No, I've been lucky to have 4 acceptances, but we'll see.
Did you get the one that you wanted?
Yes, I did.
Yay! That's right. All right. Okay.
All right. Well,
we might have work that can help you make some money.
Awesome. So I don't have to live with my parents anymore.
You should stop that.
I'm just kidding. So I definitely want to look in. It's the interesting part. If we are going to do this, is the way for the community to communicate. What they need, what's working for them. And also, certain tags so that people that are not, in this space could quickly find the solution that they want. Because what I'm guessing is what we're going to see happen is somebody in their community, has a friend who needs a certain device, and they look online and making it really easy to be like, oh, like, my cousin, does these things, and then send them the AT Makers way, and they don't, and they realize, wow, I can put this together, or something like that. That's one part. And then the other part is for us also to get feedback on which of the devices are getting like good reviews, people using good success stories to try to gauge what we should put together to do mass production. To try to get that lower cost, but then also finding that third party. So I don't know what that looks like. Is that Facebook? I don't think it's Facebook. I
wish we weren't in Facebook at all.
Right. Yeah.
But that said, it is where the support groups are, and it is where people find us. So some of the conversation needs to stay there about the community and what people need, right? And the success stories need to get posted there. Right?
Yeah. So
the tactical part of how are we making this, it is not the best place for. And I just posted on there. I don't know if you've looked. I'm sure you've looked at Makers Making Change. Yes.
Yeah.
So they have tools for getting matched up with a maker, and they have tools for finding all of the projects, and they catalog all of our projects because they ask me for details all the time for different types of key guards and lip syncs and switch interfaces and things like that. So like this is my project, the My Pal Scouts, my design, it was my video that did it. They took it, turned it into a project on their site, made the box that holds the jacks and stuff. And we've had the conversation about not replicating this.
Right.
And listen, they got a Canadian grant for $1 million to do this. You do it, right? Sold. Canadian government can pay for this one, right? Chad, it turns out, was here, and I had the database that I was going to make on the whiteboard, and he happened to be here because he was visiting his mom or something. And he's like, "Well, we're in the middle of making that." I'm like, "Great, you make it. I don't want to make it." So we also need to remember that when these things exist, we need to direct people to them, right? And if they're not good enough, or if they don't have the things that we need them to, especially the open source ones, we need to get them up there. And usually, what that really means is tell Jake or Chad, and then offer to answer questions, right? They're not asking you to make videos for them and go. They'll make the project, but you just need to make sure that they have the things that they need to make it repeatable. So this is, I am not trying to make this view of the AT maker world. I'm going to call it AT makers, but this view exists. End users looking for projects that might help their friends. We need to make this more findable, right? And we need to support it where we can. But I don't think GitHub's going to solve this problem at all. GitHub's going to make it easier for us to not replicate our work and to find out which technical things work and which don't. Does that make sense? Whoops. Yes?
Yep.
Yep. Okay. By the way, Joe, have you seen that?
Seen which? What are we talking about?
The Makers Making Change site and all the different projects that they have.
I think Mary Elizabeth showed it to me, and
yeah,
haven't really tried to do anything with it.
Gotcha. So I hope that answers your question. I'm mainly trying to focus on the people who are actually designing these boards right now and making their lives, stopping the repeating, stopping the double work and triple work and 10x work we're doing right now. So, make sense?
Yeah.
Yeah. Okay. All right. I think my takeaways are make a video that shows how to make parts out of footprints. Stand up a basic first pass through at the GitHub repository, and circle back with the same group that we talked about here. Everybody who I sent the message to and that we invited. And I always keep Phil and Lamore and folks, Dan Halbert over at Adafruit kind of aware of what we're doing. I will let you know if I hear any feedback from them of, is this worthwhile, or is there a better way they think of for us to do it? Right. So maybe it makes sense for us to do this work, but to have it live in their PCB repository, right? Because then people would just find that one, even if they weren't AT people, right?
I did a real quick search on Google or of GitHub and Eagle libraries, and it looks like SparkFun has a kind of a similar concept. Excuse me, my dog.
That's a yippy little dog. That's a kick it dog.
Two huskies playing together.
They're little huskies then, right?
They are, yeah.
Okay.
They're young. But SparkFun has some type of thing like this that they've started. So I imagine that Adafruit has, they have thought this through pretty thoroughly. So they've got to have some idea too.
Okay. Well, I will bounce this off of them again. And probably Dan, by the way, if you ever are trying to reach out to somebody on the Adafruit, in Adafruit, like you want to reach somebody there, their Discord channel, you can pretty much find all of them there. And Dan Halbert is their official liaison to the AT community. And he's great. He lives in Boston. He's an MIT professor. Reminds me a lot of Joe. He actually, here's the cool thing that some of you will get. The older folks, Jay and I will get, and other people in the chat. He wrote more. Right? Jay's impressed, and Mary Elizabeth thinks that's a weird sentence. More is a computer program that gives you text files one page at a time. And it was written in 1970. And he's the guy who wrote more, which is just, I love that. Joe hasn't used more, pipe to more.
He was a Fortran computer science professor.
Yeah.
Not a professor, but a lecturer, I guess you do.
Yeah. So Dan's great. So he's also somebody that you can ping on Discord and bother, and he doesn't mind. He'll be so glad that I said that out loud on a video. So, all right, let's wrap this up, guys. I appreciate you getting together, and Jay, is good to see you. We kind of have a possible meeting on Friday, or that's tomorrow. Are we trying to get together tomorrow with Chris?
I would love to. Yeah.
I'll talk to Chris and see if he can. I should have asked while he was here, but he didn't. For those of you who are not here, I'm sorry you couldn't join us. To those of you who left early, who left before now, like Paul, thank you, Paul. Thank you for starting this conversation. And just like the risk discussion, we haven't solved anything, but I still think it's worth having the conversation, right?
Absolutely.
Yeah.
I got some notes.
You have just a few notes?
I have 2 notes.
All right, Mary Elizabeth, Jay, Joe, thank you. Bye, everybody else.
Take care.
Nice seeing you again.
Yeah.
Thanks, Bill.